So if we discuss about the third point, so third point will be that there is a phenomena or they follows different properties of wave as we discuss in the chapter or in the topic of ripple tank, that they perform reflection, refraction and diffraction. These all types of process are going to be involved in electromagnetic waves also, right? Because they are transverse in nature, so they follow the same procedure as we previously discussed in the topic of ripple tank. So this is the third point, that the electromagnetic waves also contains reflection, refraction and diffraction process because they are transverse in nature. So this is the third point. And if we discuss about some other points related to this, so the fourth point is that they can transfer energy or they can carry energy from one point to another or from one place to another, because these are type of waves. So the basic property of wave is to transfer energy from one place to another, right? So this is an other property of electromagnetic waves. So these are some properties related to electromagnetic waves, and most of the concepts are the old one we already discussed in previous topics and in previous chapter. And now if we discuss about a specific type of electromagnetic waves starting from light waves. So let's start with different individual property or different individual waves in the detailed form. So first, if we discuss about the light waves, so we discussed in our previous class that there is a different range of different type of waves, and light is in the middle of all those waves, because on left hand side there are gamma rays, x-rays, ultraviolet light, and on right hand side infrared rays, microwaves, TV and radio. So light waves are in between of all these types of waves. So if we want to list down some properties or some characteristics of light wave, so let's first start with the property of light wave. As we already discussed about light, that speed of light and nature of light waves both are transverse in nature. So first of all, light waves are in the visible region because we can observe or we can see light with our naked eyes. So which means that these types of waves are visible in range. So you can easily observe or you can see light waves with your normal eyes. And if we discuss about different colors, we already discussed in the topic of dispersion. So different colors have different wavelength and different frequency. So if we specific mention frequencies and the wavelength of some light rays, so red light, if we first mention the property of red light, so red light has the longest wavelength. Red light has the longest wavelength, and if we want to mention the value of the wavelength, so the exact value for the wavelength of red light is 7 into 10 to the power minus 7 meters, or we can write in the form of scientific notation which is equals to 0.7 micrometer. This specific symbol is used for micro. So this is the exact value of the wavelength of the red light, right? And if we discuss about the shortest wavelength, the shortest wavelength will be of violet light. You just need to remember the graph of the waves we already discussed in our first class. So if you remember the range of the light rays and the other type of electromagnetic spectrum, so you can easily identify the wavelength and the frequency of different waves. So if we discuss about the shortest wavelength or the violet light, so violet light has the shortest wavelength. Shortest wavelength of violet light, which is equals to the exact value of violet light is 4 into 10 to the power minus 7 meters, or you can simply write 0.4 micrometer. Again, this new symbol represents the micro value, which is equals to micrometers, right? And all other lights which are in between this red and violet light are in intermediate values or in mid of these values. So we just need to remember the highest and the lowest one. We don't need to remember the all values of the wavelength and the frequency. So just want to know about the highest and the lowest one. And we discuss about the monochromatic term. Let's suppose if they ask about what is monochromatic light. So if we discuss about monochromatic nature of light, so monochromatic light means light wave with single frequency. So light wave or you can say that light of one color having single wavelength or a specific wavelength is known as monochromatic light, right? Single wavelength is
Yeah.
known as monochromatic. So these are some properties of light waves which are in 7 different colors we observe in the phenomena of prism. So we easily understand or we can easily identify the highest wavelength and the shortest wavelength, right? And the speed of the waves are same as equal to the speed of light, which is equals to 3 into 10 to the power 8 meter per second, right? And if someone asks that if you want to identify or why the colors of the waves are going to be changed, so what is the reason behind the change of colors of light waves? So what is the reason? Is it wavelength or frequency?
Wavelength.
Wavelength. So if someone asks about the color of light, so just remember one thing, that color of light waves, color of light waves depends upon it depends upon the frequency of light waves, right? Sorry, it depends upon the frequency of the light rays. So frequency is the reason because when we are discussing about the dispersion, so I already mentioned there that light is going to be split into 7 colors because of different frequencies, right? So different frequencies means different colors. So the colors of light depends upon the frequencies of wave, right?
Yes.
So just remember this thing. If they ask about the color, so just remember one thing, that they depend upon the frequency. And if we discuss about some other properties, let's suppose if we discuss about the amplitude, there is an other factor we discuss in waves, which is of amplitude. So if we increase the amplitude or if we decrease the amplitude, so what will be the effect on the light wave? Increase or decrease? So we discuss about the color, we discuss about the wavelength, and if we discuss about the amplitude of light, so if we increase the amplitude of the light wave or if we decrease the amplitude of light wave, so what is going to be happen with light wave? Any guess about it? Basically, amplitude links with the intensity of light, intensity of light. And if we increase the amplitude, or you can say that if we increase the intensity of light, so light is going to be bright. So brighter light means that the light wave which is coming very bright in color, which means that that light is of very high amplitude or high intensity. And if we decrease the amplitude, so by decreasing the amplitude, light will be low in brightness as compared to the above one. So amplitude will affect the brightness of light. So this is an other factor on which light depends. So these are some factors which is related to the wavelength, which is related to the frequency and related to the amplitude, right?
Yes.
And this is basically for all type of light waves which are going to be present between red or violet color. And if we discuss about some other types of wave, because there are so many types of waves just like ultraviolet, infrared, x-rays, microwaves, because we only discuss for light wave. So this is only a single property or single range of electromagnetic spectrum. Now if we discuss about some other examples or some other types of wave, so the next one is of infrared. So the next one is the infrared radiations, because these type of waves cannot be observed with our normal eye, so that's why these type of waves are known as radiations, because these waves are invisible, so that's why we cannot observe or we cannot see these type of radiation with our normal eyes, right? And when we are using or heating some object or solid material, so in that process, waves are going to be radiated from that material which are completely invisible. And we already discussed in the general properties of waves that there are three types of radiations, and some are known as transfer of thermal energy, conduction, convection, and radiation. So this is also lie in the third category, which is known as radiation. So that's why these types of waves are invisible, right? And we can generate these types of waves by heating effect, like microwave and different types of waves. So we can also create these
Yes.
types of waves with the help of heating effect. And if we take common example of infrared radiation, there is an other example of our TV remote or TV control, because there is a sensor in front of a remote. When you press a button or when you want to change the channel of that TV, so you just simply press a button and there is an LED which is placed in the front of the remote. So when you place that remote in front of your TV or LED, so the channel is going to be changed. So that LED emits radiation, or you can say that a light of infrared radiation that catches the signal of TV, and the channel or the volume is going to be changed. So that waves are invisible. We cannot observe, or we cannot observe these type of waves with our normal eye. If you place a camera of your phone or some other camera in front of that remote, then you press the button, so you can easily observe that red light or type of orange light coming out from that remote when you press the button, because camera can observe that radiation or that infrared radiations, but our normal eye is not able to catch those radiations, so we cannot see the color of that light, right? So there are some other
Yes.
example also. We already mentioned the heating effect, or if we take the example of toaster, so same process goes in the toaster, because the material in the toaster is already heating up. So there are other radiation which are coming out from that toaster, which is also known as infrared. Or you can say that the electric grill also emit radiations which are known as infrared. So these all examples are related to the infrared radiations, because we cannot see those radiation with our normal eyes. And if we take another example, the filament bulb. So filament bulb, in the filament bulb, the metal is also going to be heat up, and with the help of fluorescence, we can observe the light of that material. If we remove the fluorescence or the shining material from the bulb, so we cannot see or we cannot observe the radiation of that material also, right? So these are different properties of infrared as compared to the light. And if we discuss about more examples, we discuss about the TV remote, and if we observe CD drive, DVD drive, so these all examples contains infrared radiations within. So these are infrared radiations which are normally invisible, cannot observe with our normal eyes. Okay, any confusion in it?
No.
Okay, and if we further discuss about some other types of waves, that is ultraviolet radiation, that is known as UV radiation also in short form. So ultraviolet radiations, and if we revise the previous topic of that table, which is already mentioned for ultraviolet rays, so ultraviolet rays which is mentioned here, So ultraviolet lies in the low wavelength and high frequency range, right? So ultraviolet have less wavelength and greater frequency. And if we compare it with the infrared, so infrared waves have higher wavelength and less frequency. This table is very much important. If you remember the all values from this table, so that becomes very easy to identify or differentiate different types of waves and radiations, right? So if we discuss about the ultraviolet radiations, so that are shorter in wavelength, shorter wavelength. And what about the frequency? High frequency. So ultraviolet radiations have shorter in wavelength and greater in frequency. And this also produce the you can say that ultraviolet light produce or ultraviolet radiations can produce fluorescence effect. And if we discuss about different rays, just like we normally use in the hospitals to treat different diseases. So in medical field, there are many equipments. We used ultraviolet rays on those equipments to treat some diseases or some type of treatment which are also related with the ultraviolet radiations. Okay. And there is a very important application of ultraviolet radiation, or you can say very interesting one, that these type of radiation can also used in security marking. And what is security marking basically? In security marking, they use ultraviolet radiation to make a sign or to write some security code that cannot be easily, or you can say that that cannot be visible with our normal eye. So we have to use some kind of color light to observe or to see that signature. So this is an other application of ultraviolet radiation to make invisible signatures. This example is just like same of that cheating pen we observe some years back that some students used to write with that cheating pen in their copy, and when the test is going on, so they use blue color light over that pen, and that invisible ink is going to be visible with the help of that light. So this ultraviolet radiation security signature also works on that principles, right? Because when some light reflect on that radiations, so they produce fluorescence effect, that writing going to be reflect in the light form, so we can observe that radiations with the help of other light or some different process, right? So these are different types of waves and some different properties if you want to discuss in detailed one. But if you remember that table we previously discussed in our class, so that gives you much help to remember the range and to remember the values of frequencies and wavelength, right?
Yes.
And there are some other type of waves, just like radio waves. because there are many questions. You observe the value of radio waves which are mentioned there. So if we discuss about radio waves, so if we want to write the wavelength of the radio waves, so radio waves have longest wavelength or the shorter wavelength. Radio waves have longer wavelength, and which means that they have low frequency, because if they have larger wavelength, so they have lower frequency, and if they have shorter wavelength, so they have high frequency, right? And these are known, or you can say that radio waves can also use to carry pictures, videos, sound over long distance. So these type of waves helps you to transfer these type of media to longer distance. So radio waves help us to travel these type of media to a larger range or very large distance from one point to another. That's why you see or you observe that normally police officers or the cops are using some specific type of frequency of radio waves. So when they are going to connect with their headquarter or their office, so they set the frequency and then turn up the radio. They directly connect to that specific quarter or some that specific office, because radio waves can travel in the lower, or sorry, in the greater distance, so they can easily carry their voice, they carry their sound to the longer distance. So this is the reason why they use radio waves, and radio waves are very easy method to transfer signals from one point to another in a wider range, right? And if we discuss about the, if there is some obstacle or there is some medium or some type of object between 2 points, let's suppose sound is going to be produced at one end. If suppose there is a medium and there is a hill and someone is producing a radio waves from this point, waves are so due to the process of diffraction there is a process of diffraction, because this hill has some rough surface or obstacle in between the direction of waves. So from this curved surface, waves are going to be diffracted. And if someone is standing, or you can say that someone is standing to receive the signal at this point, so due to the process of diffraction, the waves can easily travel in this direction. So that's why radio waves can easily travel to a larger distance, because they helps to travel from one place to another with wide range of distance, right? And in antenna or the signal poles of telephones, you observe that telephones are at a specific point and there is only one tower which is covering whole area of that. So all telephones or mobile phones are connected to that tower, because in mobile phones and in that tower, they both are working on the principle of radio waves, so they can easily catch the signal and the frequency of that phone and can easily communicate to the other tower with the help of radio waves, right? So radio wave is very much important and it is very useful in our daily life. Our mobile phones, telephones, and media basically working on the same principle of radio waves, right?
Yes.
So we can write for X-rays that they are of high frequency and of shorter wavelength. Since they are short in wavelength as compared to the ultraviolet rays or ultraviolet waves, so they can easily penetrate through the smaller gap or through the smallest, or you can say microparticles, right? This process or this term X-ray we use in the hospital or the medical terms to identify or to diagnose the injury in the bone or in the tissues or in the muscles, right? So we are using X-rays because they are short in wavelength. They can easily penetrate, and due to this penetration power, we can use them to diagnose the defect in the bone or defect in the muscles or in tissues. So this penetration help us to diagnose defects or gap, or you can say any type of injury in bones or muscles or in tissues. So this really help us to identify these type of defects. But there is an other factor, or you can say the disadvantage of using this X-ray. Let's suppose if someone have to uh, make two or three X-rays of his body or her body, so doctor recommends that only test or only make one X-ray at a single time. Do not take three X-rays of your body at single time or in single day, because these rays or these radiations are very dangerous for human body because they can easily penetrate through the body. Okay, only bones can, because only bones can stop the path of the rays, and bones can only stop in our body to travel from one point to another through our body, and through the tissues, through the muscles, they can easily penetrate, or they can damage or can make muscles or tissues weak as compared to our initial state, but they can be stopped with the thickness of bone. So when we use X-ray to identify the injury or the defect in the bone, so whenever there is a gap between any bone or any defect in the bone, so these radiation can easily pass through that bone, right? And on the darker side or on the brighter side, when you saw any X-ray, so let's suppose if there is an X-ray of some bones of our human body, so some part are going to be lighter one or the brightest one, and some part is going to be very dark. So the dark part, let's suppose there is a dark fringe between these light fringes. So this dark fringe means that ultraviolet rays can pass through this gap, right? That's why the image or the picture of the X-ray is going to be dark. So this is due to the penetration. That's why this part of the X-ray is going to be dark. And if we discuss about the brighter side, so this brighter side represents the bones of our body, which means that ultraviolet rays cannot penetrate or pass through this brighter side or the brighter end of our bone, right? So if there is a gap or there is a dark fringe between the brighter one, which easily indicates that there may be some defect or some injury in the bone, that's why bone is going to be broken or some gap between the bone. So ultraviolet rays can easily penetrate through those gaps and we can get the picture of that bone structure on a photographic plate or a photographic sheet. We can easily identify the gap or the damage between the bones, right? Any confusion?
Yes. No.
So this is the medical application of this X-ray, which help us to identify or detect the broken bones. But these are also very harmful or very dangerous to our body. So that's why we diagnose or we try to make this X-ray after long time. So our tissues and bones are not going to be very much affected after passing these X-rays through our body, right?
Yes.
And we can use this process also in our security system. This is an other application that we can use these X-ray in our security system, like on airport or some security, high security areas. We use that X-rays to scan bags because these waves can easily penetrate through the soft material. So if there will be some solid material or like some explosive material, so that materials are going to be solid. So ultraviolet cannot cross that solid material and they get the picture of that material on the screen, which detects there is something solid in that bag or in that luggage, right? So this also helps us in the security purpose also because there is a very basic concept that this is of very shorter wavelength and can penetrate through any soft material but cannot penetrate through the solid one, right?